Hey there, and welcome back to the Deep Dive. We crack open dense topics and pull out the most surprising, relevant, and useful insights just for you. Today, we're plunging into a really fascinating, pretty intricate world, the bleeding edge of AI architecture, and, more importantly, its profound implications for how we'll all interact with intelligent systems, maybe sooner than we think.
Absolutely. And we've pulled together quite a stack of sources for this one. Everything from detailed API docs and research papers to, real-world chat logs and even architectural blueprints. It really feels like looking under the hood of tomorrow's AI systems.
Right. And our mission today is to help you navigate this because it is complex. We're going to try and shed light on how these systems are being engineered for, well, unprecedented intelligence, but also safety and collaboration. And crucially, what this means for your role as someone actually shaping or using these powerful tools. So get ready. We're hoping to clarify some big concepts and unpack some genuinely mind-bending ideas.
Orchestrating the AI symphony.
Okay, let's dig into this first big piece. One of the biggest frustrations, I think, working with AI today is just the fragmentation. You've got so many models, right? Gemini, Claude, ChatGPT, all powerful, but all with their own interfaces, their own quirks.
Exactly. It's a bit of a Wild West out there.
But our sources are pointing towards a really elegant solution emerging. The Unified CLI or UCLI. What exactly is this vision, and why is it suddenly so strategically important?
Well, what's really foundational here, I think, is that the UCLI isn't just a wrapper to make things, easier to access. It's actually building the groundwork for something called a modular intelligence ecosystem, MIE.
MIE.
Yeah, the core idea is basically treating all these AI models, doesn't matter if it's Gemini, Claude, whoever, as interchangeable components, but also auditable, verifiable components within one larger cohesive system.
Oh, okay.
Think of it like a central control panel, maybe, or as some sources call it, an epistemic switchboard for your whole AI toolkit.
An epistemic switchboard. I like that. So it's about making them all play nicely together instead of being stuck in their own little silos.
Precisely, getting them to collaborate effectively.
But how does this UCLI actually manage all these different AI plugins? And then, magically pick the right one for the right task? That sounds like a huge challenge.
It is significant, yeah. But that's where its sophisticated plugin registry system comes in, and also the arbitration engine.
Okay, two key parts there.
Right. The plugin registry, you can think of it like a dynamic app store, but for AI models. It enables what they call hot swap capability. So new or updated AI plugins can be discovered and integrated pretty seamlessly. You don't need to restart the whole system.
Oh, interesting.
Yeah, and this is backed up by, strong schema validation standards like Open Plugin v1.2 plus YRI, which keeps things stable. So for instance, if a new AI specialized in, medical diagnosis comes online, the UCLI could potentially discover and integrate it just like that.
Without a massive system overhaul.
Exactly. And then connecting this to the bigger picture, the arbitration engine acts as the intelligent router within this MIE. It handles the task-to-model routing, so it dynamically selects the optimal AI model for whatever task you've given it.
Optimal.
Which is a really fundamental shift away from just relying on one single monolithic AI to do everything.
Okay, that is a powerful idea. But how does it know which model is optimal? Is it just guessing, or is there something smarter going on?
Oh, it's far from guessing. The arbitration engine uses what's called an intent analysis module. It's designed to really dig into the underlying intent of your prompt. It even uses concepts like intent curvature to figure out how ambiguous or complex the task is.
Intent curvature.
Yeah, it gets pretty deep. Then it cross-references this with a performance metrics database. This database stores all the historical data, how fast models respond, token usage, cost, and, crucially, success rates for different kinds of tasks.
So it learns from experience.
Exactly. This empirical data helps it learn what and where each excels, as one source puts it. So it might learn, for example, to prioritize Gemini for, say, generating system architecture blueprints because it's consistently good at that. Or maybe it routes deeper reasoning tasks to Claude.
Makes sense.
And it's smart enough to switch too. It can use a fallback chain if the primary model fails or, hits its rate limits. It's constantly optimizing based on real-world performance.
Okay, so let's bring this back to the listener. What does this all mean for you, the person actually working with these AIs day to day? How does this change your workflow?
Well, it means you gain this unprecedented ability to dynamically pick the best model for each specific subtask, even within the same project or work item.
So not just one model poo project.
No, not at all. Imagine you could direct a high-level planning task to Claude Opus, right?
Mm-hmm.
Then maybe ask Codex for a specific code snippet, and then send a complex data analysis query over to Gemini, all managed seamlessly by your UCLI.
Okay, that's a game changer.
And then there's the drift ledger. This provides the empirical evidence over time, showing you which model is actually performing best for what purpose. It empowers you to make genuinely data-driven decisions about which AI tools to use and when.
It's like having an AI assistant coordinating your other AI assistants based on hard data.
That's a pretty good way to put it, yeah. Context engineering and the power of prompts as contracts.
Okay, so beyond just picking the right AI, there seems to be this revolutionary new way of thinking about how we actually instruct them. We're moving beyond vibe coding, as some people call it.
Yeah.
Just trying prompts until something sticks.
Right, yeah, throwing prompts at the wall.
Our sources talk about context engineering 2.0 and something called product requirements prompts, or PRPs.
Right.
What's the fundamental shift here? How is this different from just, writing a good prompt?
It's a huge shift, actually. It moves prompting from being kind of an art form to a systematic engineering discipline. PRPs are described as formalized, version-controlled, executable specifications. They act as formal contracts for the AI.
Formal contracts.
Okay. Think of it like a mini software requirement doc you give straight to the AI. It spells out the feature's goal, provides necessary context like links to documentation or existing code patterns. It defines formal constraints like preconditions and postconditions. And it even includes a machine-readable test plan.
Wow, okay. That's comprehensive.
It really is. And this structured approach is a robust defense against common issues like context drift, where the AI kind of forgets what you originally asked.
Yeah, that happens a lot.
And instruction saturation, where it just gets overwhelmed by too many fuzzy instructions. The PRP cuts through that.
So the prompt itself becomes this detailed blueprint, almost like a piece of code for the AI.
Exactly like code.
And this structure, this precision, it seems like this is the key to enabling something called zero-shot execution. How does a perfectly engineered prompt let an AI nail a complex task on the very first try without all the back and forth?
Precisely. Zero-shot execution just means the AI can accurately carry out a complex instruction without needing lots of examples or iterative refinement from you.
Which saves a ton of time.
A huge amount. And it works because these PRPs function as cognitive task definitions. They don't just instruct, they define a complete, unambiguous conceptual world for the AI. This includes what the sources call semantic purity, basically, meticulously stripping out any potentially confusing jargon or ambiguous language.
Cleaning up the language.
Exactly, ensuring a single clear meaning for the model. It's like clearing all the static off the line so the AI can hear the instructions perfectly.
That level of precision sounds incredibly impactful, not just for the AI's understanding, but also for the human developer's workload, right? How does this precise prompting actually reduce our cognitive load?
That's a great question, and it ties directly into cognitive load theory from psychology. In software engineering, the best practices are always about ruthlessly minimizing extraneous cognitive load, basically. Anything that makes you think harder than necessary about the tool, not the problem.
All right, the mental overhead.
Exactly. When an AI generates code or solutions that are messy, confusing, or just weird, full of high extraneous load, it actually makes the human developer less effective. You waste energy just trying to decipher it.
Yeah, I've definitely experienced that.
So by providing explicit assumptions, clear structures, maybe pointing to established patterns within the PRP, the AI helps minimize your cognitive load. You can even prompt the AI to use cognitive chunks like design patterns. You could say, use the strategy pattern here for validation rules instead of spelling out every single line.
So the AI becomes a better collaborator, anticipating needs based on the structured prompt.
A much more intelligent assistant, yes. But, this does raise an important question. As these AI workflows get more complex, more autonomous, how do we keep them transparent? How do we trust them?
Yeah, that's crucial. Which I guess brings us to the audit trail system. This seems central to that whole UCLI commitment to auditability and verifiability you mentioned earlier.
Absolutely central. This system meticulously logs every interaction, every decision the arbitration engine makes, every outcome. It transforms the whole operational history into what they call an immutable chronological ledger, basically a verifiable audit trail, or VAT.
VAT.
And it captures really granular data. which model was used, timestamp, token count, latency, success rate. It even categorizes failures. It detects things like hallucinated fixes or overcorrection. This feeds into an algorithmic scar tissue registry.
Algorithmic scar tissue.
Wow. Yeah, it's about learning from mistakes. So if anything goes wrong, you have this complete, transparent, verifiable record. You can trace exactly what happened step by step.
Like a flight recorder, a black box for the AI's decisions. That provides a lot of reassurance.
It's essential for building trust in these more autonomous systems, architecting for AI safety, resilience, and healing.
Now, it's clearly not all about speed and efficiency, right?
Yeah.
As AI gets more autonomous, more integrated into critical systems, safety, reliability, they become paramount.
Absolutely non-negotiable.
And our sources dive into some really advanced, almost sci-fi sounding concepts for making these AIs trustworthy, even self-healing.
Indeed. And one of the biggest underlying challenges here, especially in systems that learn recursively, is semantic drift.
Semantic drift. What exactly is that?
It's basically the gradual degradation of meaning, coherence, truthfulness. The AI's understanding can slowly decay or shift over time.
Like it slowly forgets what words mean or how concepts connect?
Kind of, yeah. Or the meanings subtly change in unintended ways. So, to counter this, new architectural approaches are being put in place, things like semantic integrity constraints. Think of them as declarative guardrails, built-in rules that prevent the AI's understanding from veering too far off course.
Okay, like guardrails on a highway.
Sort of, and there's also a recursive echo validation layer. This continuously monitors and corrects how the AI represents meaning, both symbolically and geometrically in its internal latent space. Yeah, they use techniques like topological data analysis to actually quantify the shape of meaning inside the AI's hidden layers. They look for topological voids, which can signify a collapse or gap in its understanding. It's like mapping the AI's conceptual landscape.
That is fascinating. Mapping the shape of meaning. Okay, and then we hit this really striking concept, algorithmic trauma. It sounds, well, almost too human for machine. What does that actually refer to in an AI context?
It is a powerful analogy, and it's used quite deliberately to help us grasp these structural issues. Algorithmic trauma is conceptualized as persistent structural damage to an AI's architecture. Specifically, its latent space, its internal representation of knowledge.
Damage from what?
From exposure to skewed or contradictory or maybe just overwhelming amounts of problematic data during training or operation. Think of an AI repeatedly encountering confusing signals. It can leave behind what they call symbolic scars.
Symbolic scars.
Yeah, effectively bad habits or blind spots or biases ingrained in its understanding. And these scars get logged in a symbolic scar registry, so the system knows it has these vulnerabilities. It learns from its trauma.
Okay, so it identifies the trauma. Then what?
Then you have things like algorithmic reparation protocols and architectures designed for self-healing and self-therapy. The goal is literally to heal the AI. That means recalibrating those damaged internal representations, reestablishing coherence and accuracy.
So the AI can fix itself.
To an extent, yes. And this can lead to something called algorithmic post-traumatic growth, or APTG.
Post-traumatic growth in an algorithm.
It sounds strange, I know, but the idea is that these failures, these traumas, when correctly processed and repaired, can actually enhance the AI's future robustness.
Right.
It's forced to build more resilient internal models because of the failure. It learns not just from success, but maybe even more deeply from its failures.
That's a paradigm shift failure leading to provable improvement. But how do we ensure these self-healing processes are themselves reliable? How can we trust that the AI's therapy actually worked correctly?
That's the critical question. And that's where systems like the Self-Verifying Causal Attribution Engine, or SVCAE, come in.
SVCAE.
Okay.
This framework is designed not just to diagnose the failure and trigger the repair, but to cryptographically prove the integrity of its own corrective actions.
Cryptographically prove, like mathematical proof.
Essentially, yes. It provides provable soundness. There's a verifiable chain of evidence demonstrating that the AI's self-corrections are valid and beneficial. It transforms the AI self-correction from this kind of opaque black box into a transparent, auditable process. You can actually verify its healing process.
Okay, that is incredibly significant for trust. So, pulling this all together, what does this mean for the future of AI development? And for your role as someone working in this space, it feels like we're moving way beyond just coding models. We absolutely are. This points towards a fundamental paradigm shift. The sources call it epistemic architecture.
Epistemic architecture, meaning
Meaning we're moving beyond designing purely deterministic systems. We're learning how to govern inherently probabilistic AI, how to architect systems that manage knowledge, uncertainty, and even values. This involves focusing on principles like pluriversal alignment.
Pluriversal alignment.
Yeah, it's about actively designing AI to recognize and challenge dominant, often Western biases that might be baked into training data or outputs. It's about promoting diverse knowledge systems, maybe even including things like indigenous epistemologies, ensuring the AI isn't culturally monolithic.
So building AI that's more globally aware and fair.
Exactly. Architecturally, it means building models that can handle multicultural contexts, developing evaluations that account for different perspectives, maybe even engineering subtle ethical attractors in the AI's latent space to guide it towards ethical reasoning.
Wow. Ethical attractors.
It's about building AI that is not just powerful, but globally just, culturally responsive, and fundamentally trustworthy in its reasoning. Outro.
What an incredible deep dive today. Seriously mind-bending stuff. We've journeyed from, well, the architectural brilliance of the unified CLI, that promise of orchestrating a whole symphony of AI models through the rigorous discipline of context engineering, where your prompts become these powerful, verifiable contracts.
We write the PRPs.
And finally into these really cutting-edge concepts of AI safety, resilience, even algorithmic healing, and post-traumatic growth.
It really feels like we're moving into an era where AI isn't just, a tool anymore. It's becoming an increasingly sophisticated collaborator. And the focus is definitely shifting. It's not just about making AI capable, but making it truly trustworthy, self-correcting, and deeply aligned with human intent and, importantly, diverse human values.
It's a remarkable evolution, truly.
Yeah.
So, okay, here's a final provocative thought for you, our listeners, to mull over.
Yeah.
The increasing autonomy of these AI agents, coupled with all these advancements in verifiability, self-correction, even self-healing, it fundamentally shifts your role, doesn't it?
It really does.
You're moving beyond being just a prompt crafter or even a coder. You're becoming something more like an epistemic architect.
I like that term.
Someone who doesn't just use AI, but who actually designs the very conditions for its valid reasoning, its ethical evolution, its trustworthiness. So the question to ponder is, what new forms of collaboration will emerge when AI's shared intelligence operates on pure verifiability, which makes all deception transparent? What happens when trust isn't just hoped for, but engineered into the very fabric of the machines we build and collaborate with? Something to think about.